Bismillahirrahmanirrahim. Welcome to Al Munir High School e-learning system, class 9. Today we are going to discuss and learn about unit number 5. Its topic is gravitation. This is title page of your physics book for class 9. Unit number is 5. It is about the gravitation. Major concepts of this unit is about law of gravitation, measurement of mass of earth, variation of gravity with altitude, and motion of artificial satellites. First of all, look at the introduction. It is about the scientist Isaac Newton. It was an evening of 1665 when he was trying to solve the mystery why planets revolve around the sun. Suddenly an apple fell from the tree under which he was sitting. The idea of gravity flashed in his mind. He discovered not only the cause of falling apple but also the cause that makes the planet to revolve around the sun and the moon. So this unit contains the topics about the gravitation and gravitational force. First of all, the force of gravitation. What is force of gravitation? If we look at on the basis of Newton's observations, what Newton concluded? He concluded that the force which causes an apple to fall on the earth and the force which keeps the moon in its orbit are of the same nature. He further concluded that there exists a force due to which every body of the universe attracts every other body. So according to his law, here we have this pink box. So according to Newton's law, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses. Here we have the product of masses m1 and m2 and inversely proportional to the square of the distance between their centers. So here we have the distance between their centers. So consider two bodies of mass m and mass 2. So here students, we have two bodies of different masses. The distance between their centers, yes, it is d. So F is equal to g m1 into m2 over d2. So figure 5.1 shows two masses attract each other with gravitational force. So according to this law of gravitation, the gravitational force of attraction F, with which the two masses m1 and m2 separated by a distance d attract each other. So it means that force is directly proportional to m1, m2, and force is inversely proportional to the distance between them. So we can say that force is equal to or proportional to m1 into m2 over d2, where g, here we have the g, which is proportionality constant, and it is also called universal constant of gravitation. So students, its SI unit and its value is fixed. Please remember and learn this value because we will use this value in our numerical type questions, which is 6.673 into 10 with power minus 11, and SI unit is Newton meter square kg minus 2 or square. Due to small value of g, the gravitational force of attraction between objects around us is very small and we do not feel it. Since the mass of earth is very large, it attracts nearby objects with a significant force. Now what is the similarity between law of gravitation and Newton's third law of motion? Yes, it is to be noted that mass m1 attracts mass m2 towards it with a force F, while mass m2 attracts m1 towards it with a force of the same magnitude F, but in opposite direction. So this is the similarity between Newton's third law of motion and law of gravitation, because the action and reaction due to force of gravitation are equal in magnitude but opposite in direction, which is a statement of Newton's third law of motion. What is the statement of Newton's third law of motion, students? Yes, we have studied in our unit number 3 that for every action there is always an equal but opposite reaction. Next we have the example 5.1. Look at the statement of example number 5.1. what is given? Yes, m1 is given, which is 1000 kg. m2 is also given. Distance is given, which is 1 meter. To calculate all these things, to calculate the gravitational force, we apply this formula which we have studied in the above topic. By putting the values, we get the answer, which is force is equal to 6.673 into 10 with power minus 5 Newton. So gravitational force of attraction between lead spheres is this. Next, what is gravitational field? After learning about the gravitational force, we have the topic of gravitational field. According to Newton's law of gravitation, the gravitational force between a body of mass m and earth is given with the help of this formula, where m, this small m, represents the body of mass and me represents the mass of the earth, and r is the distance of the body from the center of the earth. This figure 5.3 shows the gravitational field around the earth is towards its center. So the weight of a body is due to the gravitational force with which the earth attracts a body. Gravitational force is non-contact force. For example, if the velocity of a body thrown up goes on decreasing, while on return its velocity goes on increasing, this is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. So such a force is called the field force, and it is assumed that a gravitational field exists all around the earth. So you students, you can take the example of a ball. If we throw it upward, after going upward, at some point it will start moving downward with some gravity and its velocity will increase. Our next topic is about the gravitational field. Yes, the gravitational field strength. What is a gravitational field strength, students? In the gravitational field of the earth, the gravitational force per unit mass is called the gravitational field strength. So it is the definition of gravitational field strength. At any place, its value is equal to the value of g at that point. The gravitational field strength is 10 Newton kg. Next, what is mass of the earth and how we can calculate the mass of a earth? Look at this figure 5.4. Weight of a body is equal to the gravitational force between the body and the earth. So consider a body of mass m. Here, students, we have the body of mass m on the surface of the earth. Let the mass of the earth, here we have the mass of the earth me, and in between them we have the radius of the earth. In the center of the earth, the distance of the body from the center of the earth will also be equal to the radius of the earth. So according to the law of gravitation, the gravitational force F of the earth acting on a body is given with the help of this formula, equation 5.3. But the force with which earth attracts a body towards its center is equal to its weight. Yes, students, we have learned it in unit number 3 that force is equal to weight, and weight is equal to mg, mass into gravity, and mg is equal to g, mass of the body, mass of the earth over radius square of the radius. Also g, if we cut the mass of the body, then the remaining g is equal to me over r square, where me is equal to r square g over gravitation. Mass me of the earth can be determined on putting the values. If we put all these values of r square, g and gravitation, we get the mass of the earth, which is 6 into 10 with power 24 kgs. Variation of g with altitude. Now we will observe that the variation of the value of g with altitude, if we take this mass at some height or altitude. So equation 5.6 shows that the value of acceleration due to gravity depends on the radius of the earth as its surface. The value of g is inversely proportional to the square of the distance from the center of the earth. But it does not remain constant. It decreases with altitude. As the altitude increases, height increases, it will decrease. The value of g is greater at sea level than at the hills. So to show this altitude, consider a body of mass m. This is a body of mass m at some altitude. So it is at some height or altitude h. The distance of the body from the center of the earth becomes r plus h. Now it is r plus h. Therefore, using equation 5.6, we can say that gravity at some altitude or height is equal to g me over r plus h square whole square. According to the above equation, we come to know that at a height equal to 1 earth radius above the surface of the earth, g becomes 1/4 of its value on the earth. Similarly, at a distance of 2 earth's radius above the earth's surface, the value of g becomes 1/9 of its value of the earth. So in this way we can find the gravity at some altitude or height. Look at example number 5.2. Here we have the values which is given. R is equal to 6,400 kilometers. H is also given. Me, we know about the value of me. We have to find the gravity at some altitude or height. So first of all, we will plus R with h. R plus h is equal to 7,400 kilometers, which is 7.4 into 10 with power 6 meters. By putting the values in the equation as we have studied in the above topic, at some altitude or height, by putting the values we get the answer. Next students, we have the topic of artificial satellites. An object that revolves around a planet is called a satellite. So this is a definition of a satellite. The moon revolves around the earth. Yes, we know that. So moon is a natural satellite of the earth. Scientists have sent many artificial satellites into space. Some of these objects revolve around the earth and these are called the artificial satellites. This is the example of or a definition of an artificial satellite. Most of the artificial satellites orbiting around the earth are used for communication purposes. Artificial satellites carry instruments or passengers to perform experiments in space. Look here students, here we have the artificial satellites. Look at its orbital radius. This is our earth. This is artificial satellite. Do you know the height of a geostationary satellite is about 42,300 kilometers from the center of the earth and its velocity with respect to earth is 0. Yes, and also we have this interesting fact about the global positioning system. GPS is a satellite navigation system. It helps us to find the exact position of the object. Next, we know that students, large number of artificial satellites have been launched in different orbits around the earth. They take different time to complete their one revolution. For example, communication satellites take 24 hours to complete one revolution. Yes, earth also completes its one rotation about its axis in 24 hours. It is due to this reason that the orbit of such satellite is called geostationary orbit. Here we have the example of dish antennas which send and receive the signals from them. Next, in the last, we have the motion of artificial satellites. Yes, a artificial satellite requires which kind of force? Yes, centripetal force. Yes, we have studied in detail about the centripetal force in unit number 3. You can revise it again to understand the concept of centripetal force. So an artificial satellite requires centripetal force that keeps it to move around the earth. So the gravitational force of attraction between the satellite of the earth provides the necessary centripetal force. Consider a satellite of mass m revolving around the earth at an altitude h in an orbit. Its radius is r0, so we can, and its orbital velocity is v0. We can say that the force of the centripetal force of a artificial satellite is equal to m v0 square over r0. This force is provided by the gravitational force of attraction between the earth and the satellite and is equal to the weight of the satellite. So which is equal to the mgh. H shows the altitude. So we can say that mgh is equal to mv0 square over r0. Yes, we also know if we cut this mass of the body, then velocity v0 square will be equal to gh r0. By taking the under root, we will cancel the square. So it will be V naught is equal to GH R plus H whole square root. So this equation 5.10, V naught is equal to under root GH R naught, gives the velocity which a satellite must possess when launched in an orbit of radius R naught, and radius R naught is equal to R plus H, radius plus height around the earth. So a satellite revolving around very close to the earth have speed V naught nearly 8 kilometers or 29,000 kilometers per hour. So students, this is all for today. Thank you. Allah Hafiz.